So we were talking about अभी नहीं आ रहा क्या था भाई बता दो कोई हेलो हेलो हेलो
Good evening, sir.
गुड इवनिंग क्या बात हम लोग व्हाट वर वी डूइंग लास्ट क्लास में
सर फ्रिक्शन कंस्ट्रेंट
फ्रिक्शन वाले क्वेश्चन कर रहे थे क्या
सर आपने बोला था वर्क एनर्जी थ्योरम पढ़ेंगे.
वर्क एनर्जी थ्योरम बोला था
सर वो काइनेमेटिक्स वाला पार्ट भी दो
काइनेमेटिक्स so what happens is that we talk about translation and we talk about rotation in the variables which describe translation x a variables describing the kinematics of rotation theta omega and alpha and the relationship between the variables amongst themselves is exactly equal to the relationship between the rotational variables. आवाज नहीं आ रही है अभी अभी आई आवाज थोड़ी मेरी तबीयत खराब है तो शायद मैं ज्यादा तेज चिल्ला नहीं पाऊंगा ज्यादा देर बोल भी नहीं पाऊंगा so the variable acceleration problems that we discussed or the constant acceleration problems that we discussed in kinematics are exactly copied in rotational kinematics. For example, I may say that look, a particle has initial velocity equal to 40 meters per second, acceleration equal to minus 3 meters per second. Find the displacement after 20 seconds. Let's say I see this. It's very easy to do. You will say that, okay, fine. You will apply S is equal to ut plus half at t square. And you will say that S is what we have to find out. U is given as 40. A is given as minus 3. T is given as 20. And you put everything in this equation and that's it. You get the answer. So the analogous question that I will give you in rotation will be something like this. A wheel rotates at omega is equal to 40 radian per second. Its angular acceleration is minus 3 radian per second square. Find angular displacement after 20 seconds. So here theta will be initial omega into t plus half alpha t square. And exactly the same thing, theta will be this and omega initial will be 40 and alpha will be minus 3 and t will be. You understand this? Everybody understand this? This is the easy
Yes, sir.
analogous problem of rotation with translation. So you see any kinematical problem in rotation. If you see any kinematical problem in rotation, then what you have to do is that you have to simply work out its analog. Simply think कि अगर ट्रांसलेशन में यही प्रॉब्लम होती तो कैसे करते, एग्जैक्टली वैसे ही इसको भी करते, सेम फॉर्मूला, सेम एवरीथिंग, symbols are different, nothing else. Symbols and units are different, बाकी सब same. Okay. So I would like to give you one problem for you to do. I'll just change the slide. So the problem is angular acceleration of a wheel is given by alpha is equal to minus k root omega. K is a constant. If initial angular velocity is omega naught, find the time when it stops and its angular displacement to this point. Right. So what I like to do is I convert it into, in my head, of course, I convert it into a translation wala problem, and then I take it from there. हाँ बिल्कुल सही. हाँ शेर बिल्कुल सही. यस यस सर. दोनों आंसर बताओ ना यार, एक एक मत बताओ. So you just convert it into that problem where somebody tells you that look, A is equal to minus k root v, and initial velocity is v naught, find the distance traveled and the time taken when the velocity becomes zero. So what you do is, instead of a, you write v dv by dx, and you write this as minus k root v. This becomes root v dv is equal to minus k dx, and then you integrate. Same thing we are going to do here. Alpha is equal to minus k root omega. Therefore, omega d omega by d theta is equal to minus k root omega. Root omega d omega is equal to minus k d theta. Simply integrate this. Yes. So टाइम वाला और भी आसान है. टाइम वाला और भी आसान है. 0 to theta जाएगा ये. ओमेगा नॉट to 0 जाएगा. Here you will get 1 by 2 plus 1. 2 by 3 by 2 2 by 3. 2 by 3 omega not raised to the power 3 by 2 is equal to minus k theta. So theta must be equal to 2 omega naught 3 by 2 divided by 3. This will be the angular displacement. Right? And finding the time is also equally easy. D omega by dt is equal to minus k root omega. टी नहीं आना चाहिए ना आंसर में. शॉर्ट टी तो निकालना है ना. तो ये हो जाएगा टी ओमेगा बाय रूट ओमेगा इक्वल टू माइनस के dt. इसको इंटीग्रेट करेंगे 0 to t omega naught to 0. So t will come out to be 2 root omega naught.
सर मैंने टी निकालने के थीटा इक्वल टू इंटीग्रल ओमेगा डी टी किया.
क्या लिख दिया?
सर मैंने टी पहले निकाला फिर थीटा इक्वल टू इंटीग्रल ओमेगा डी टी किया. आंसर सेम ही आया.
हाँ ठीक है ना. बिल्कुल सही है. बिल्कुल सही. Okay, chalo. So now let's see if we can do something good. Better question. Okay, so the next question is just find it. नहीं इसको करने के लिए तो let's see if we can go. If we can go to that. Let's see. Try to do it. I'm not sure you'll be able to do it, but still. So we have a disc rolling without slipping on rough surface. Find the ratio of kinetic energy of upper half to kinetic energy of lower half of disk at any moment in time. U कहाँ से आएगा केवल ओमेगा m और r ये सब दिया हुआ है. I don't know whether m and r will appear in the answer or not. I think it should be a I don't know. I think it should be a number मुझे याद नहीं है. Velocity तो मालूम है ना उनका center of mass का. I hope that's not a problem. If the thing is rolling, then necessarily the center of mass must have a velocity omega r. शौनक तुक्के मत मार. गलत आंसर. नहीं हो रहा है।
सर एक से
अच्छा अच्छा। नहीं पा नहीं। फिर शौनक पिट जाएगा मुझसे। वैसे भी एक महीने में पिट पाएगा, फिर बाद में पिट जाएगा। नहीं नहीं। हाँ ट्रांसलेशन भी है, रोटेशन भी हो रहा है ना, दैट इज व्हाई, दैट इज द होल मैथमेटिक्स। तो यही है ना, दैट यू फिगर आउट व्हाट। नहीं नहीं ना। तो नहीं नहीं। देखो, so I will tell you an easier way later on. Okay? I will tell you an easier way. Uh, so okay, so the problem here is how to define, how to work out the kinetic energy of the upper half and the lower half. No, no, no. आंसर में पाई भी आएगा, ये बिना पाई के नहीं आएगा आंसर मेरे हिसाब से, जहाँ तक मुझे याद आ रहा है। So this is just a mathematical technique that I want to show you. This mathematical technique may be useful in the future. In fact, it will be useful in the future, especially when we study electrostatics, magnetism. So if you have not realized the problem up till now, this is the problem. This is the problem. If I choose an element which is like this, okay, if I choose an element which is the same as the element that we have been choosing up till now, let's say that I want to find the kinetic energy of the upper half of the disk, okay, and I want to find an element जिसका मैं kinetic energy निकाल सकूं, and then maybe I can integrate. Now this is a situation you will face when doing problems, okay? And the problem is that when you choose this element, which is absolutely natural, which is absolutely the correct way to go, when you choose this element, unfortunately, each and every part of this element also has got different kinetic energies. Therefore, the reality that you will have to face in some questions. इसके लिए मैं आपको बता रहा हूँ, मैं एक छोटा method और बताऊंगा when we have done work energy theorem. Then it should be clear to you. But since this mathematical technique will be used later on, I want to show you this mathematical technique, and the technique is basically that you need to have two distinct steps of integration. So you will say that, look, I am choosing an element for which the radius is y and the thickness is dy. Okay, that's all very well, this is all very nice. But the problem is that each and every part of this element, for example, this part, will have a different kinetic energy as compared to this part. So to find the kinetic energy of the element itself, you will have to divide the element further, and you will have to integrate once to find the kinetic energy of the element, and then you'll have to integrate twice, second time, to find the kinetic energy of the whole object. Now, whenever you choose an element, of course, you must introduce new variables, and here there will be two variables, therefore twice integration. And the variables here that we are going to choose for the yellow bit will be that this angle is theta, and therefore this angle is d theta. Right? So the thickness of this element is r d theta, okay, and the breadth of the element is equal to dy. Now the thing that you have to realize and you have to be careful about,
सर वो y d theta होगा,
huh?
y d theta होगा.
y d theta. Sorry. So the thing that you have to be very, very careful about is that when you are choosing an element within an element, so once you have chosen the element, you have chosen some variable, right? In this case, I have chosen y and dy. Then when I choose an element within an element, then again I have to choose another variable. In this case, I have chosen theta and d theta. So the thing that you have to be careful about, the condition that must be met for this process to go on, is that while theta varies, that means while the second variable that you have chosen varies, first variable should not. Okay? That means that for all these yellow elements, y must remain constant. Okay? As it does, y does remain constant. So if y remains constant for all these elements, then I can take the second layer, second element, so to speak, element within an element, and I can try and find out the kinetic energy of the blue semicircle. How do I do that? Well, I will say that, look, due to the translation, this blue element has got a velocity of omega r. And due to rotation, this element has got a velocity of omega y. And the vector sum of these two velocities is the velocity of the chosen element. So velocity of chosen yellow element will be equal to under root of I would get the kinetic energy of the entire element. I only require the kinetic energy of the topper. No. Read the question. Find the ratio of kinetic energy of the upper half to the kinetic energy of the lower half of the disk. So you need to find the kinetic energy of this part, and you need to find the kinetic energy of this part. इसका ratio मेरे को चाहिए. Okay, no problems. Okay, so the kinetic energy of the yellow element, first I'm finding the velocity, then I'll talk about the kinetic energy, will be equal to omega square r square plus omega square y square plus twice omega square ry multiplied by cosine of this angle. What is this angle? हाँ भाई कोई मेरे को बता दो. What is this angle?
90 minus theta.
Cosine of 90 minus theta is sine. Okay. Therefore, the kinetic energy of the yellow element, will be half dm. Okay. Omega square r square plus omega square y square. You can take omega square common. Omega square ry sine theta, and dm will be equal to sigma multiplied by the area of the object, which is equal to dy into y d theta. Therefore, kinetic energy of the yellow element will be equal to half sigma dy omega square r square plus y square plus 2ry sine theta d theta. Right? So, how am I going to find the kinetic energy of the blue element? Any ideas? How am I going to find the kinetic energy of the blue element? Any ideas?
सर पहले विद रिस्पेक्ट टू थीटा इंटीग्रेट करेंगे देन y.
क्योंकि हमने इंश्योर किया हुआ है दैट इस पूरे एक्सप्रेशन में y और ये जो dy है ये कांस्टेंट है. ये इसमें जब हम थीटा को इंटीग्रेट करेंगे तो वो इनकॉन्सिक्वेंशियल है. Right? So kinetic energy of the blue element will be equal to half sigma y dy omega square integral of r square plus y square plus so on d theta. कहाँ से कहाँ तक इंटीग्रेट करेंगे? Since I am only interested in the upper half right now, later on I'll be interested in the lower half. Since I'm interested in the upper half, I'll integrate from 0 to pi. Chalo, now do it. Now try and do it once again, guys.
सर आपने डीएम को क्या लिखा है सर ये?
DM को मैंने लिखा है mass per unit area. Write it here. So this guy is mass per unit area. This guy is the area of the yellow patch. How is it the area of the yellow patch? Well, the width of the yellow patch is yd theta. Okay. The length of the yellow patch is dy. आया समझ में?
यस
नहीं शौनक कंप्लीट करो यार क्वेश्चन को अब. ओ ठीक है, फाइनल आंसर है क्या? लोअर हाफ का निकालो, रेशियो निकालो. I promise you I'll tell you an easier way. If you have figured out the easier way, I think you can do it also. Remember that theorem, motion is to be broken up into two parts, that is motion off the center of mass and motion about the center of mass. वो थ्योरम अगर अपन यूज करेंगे तो 2 सेकंड में हो जाएगा. लेकिन ये टेक्निक ऑफ डबल इंटीग्रेशन, this I wanted to show you. नहीं नहीं, हम तो काइनेटिक एनर्जी निकाल रहे हैं ना सिर्फ, तो उसमें फ्रिक्शन का कोई रोल नहीं है ना। एट दैट मोमेंट उस अपर हाफ ऑफ द डिस्क में जो एनर्जी है टू द लोअर हाफ ऑफ द डिस्क में जाए। So this will come out to be half sigma y dy. Very good. Yes, Parth, yes. Omega square r square pi plus y square pi plus 2 ry plus pi है ना, तो ये हो जाएगा, कितना हो जाएगा ये? साइन का इंटीग्रेशन, साइन का इंटीग्रेशन क्या होता है? माइनस के साइन, पाई डालेंगे प्लस हो जाएगा, माइनस माइनस प्लस 4 हो जाएगा। Right, and therefore now you can find the kinetic energy of the upper half will be equal to half sigma omega square is a constant sign, integration of r square pi y plus y cube pi plus 4 ry square 0 to r dy by dx। इसका आंसर क्या आएगा बात? ये अपर कितना आएगा?
सर एक सेकेंड सर, अपर आ रहा है m r square into 9 pi by 9 pi plus 16 by 12 pi
m
m r square
r square
into 9 pi plus 16 by 12 pi
by
12 pi।
ओमेगा स्क्वायर में हो गया।
सर ओमेगा स्क्वायर भी रहेगा।
हाँ सर।
तो या के ई अपर, अब इसी तरीके से निकालना है के ई लोअर। के लोअर के लिए आप कहाँ से कहाँ तक इंटीग्रेट करेंगे? यू गो फ्रॉम 0 to माइनस पाई। जल्दी करो भाई। I'll tell you the shortcut. So kinetic energy of translation is equal to half mv square. We know this. kinetic energy of rotation therefore should be half I omega square. Right? In fact, I use this to derive the concept of moment of inertia, right? And we know this because there is a direct one-to-one correspondence between the linear variables and the rotational variables. So if I have the upper half of the disk, let's say, I will consider this upper half of the disk to be a semicircle. And then I will say that, look, according to that theorem that I told you that day, the motion of this semicircle is motion of the center of mass plus motion about the center of mass. Okay. So the rotation will be omega and the velocity of this point का velocity हमें मालूम है omega r है तो ये point का velocity होएगा that will be omega r, that is velocity of velocity due to translation plus velocity due to rotation, which is omega multiplied by this distance. What is the distance of the center of mass of a half disk semicircle? याद है मैंने बोला था ना, याद रखना है ये सारी चीजें. क्या होता है? It is the, याद है किसी को या मैं याद करूं? Center of mass of a half disk 43 pi. अरे क्या बोल रहा है यार? अच्छा 4r by 3 pi बोल रहा है क्या? ओमेगा into 4r by, और ये जो लोअर वाला है उसका वेलोसिटी ड्यू टू ट्रांसलेशन विल बी इक्वल टू ओमेगा r. Velocity due to rotation will be in the opposite direction. So the kinetic energy of the upper half simply be equal to kinetic energy of translation plus the kinetic energy of rotation. Where is this coming from? ये क्या मैं अपने दिमाग से निकाले जा रहा हूँ? ये क्या हो रहा है? Well, it is nothing. It is just that theorem. Now we use that theorem to independently analyze rotation and independently analyze translation. We know, that if an object is rolling, if an object is executing translation and rotation, then the rotation velocities or the velocities of each point on the rigid body that is there due to rotation and the velocities of translation, that means the velocity of each point on the rigid body that is there due to translation of the object, are independent of each other. Of course, we don't see them as independent in our normal daily life, because if you set something rolling, then the velocity of each and every point you will see, you will observe, will of course be the vector sum of the velocities of translation and velocities of rotation. So since the concept, or since the phenomena of translation is absolutely independent of the phenomena of rotation, therefore I can immediately write this statement that, look, the total kinetic energy must be the kinetic energy of translation plus the kinetic energy of rotation added to each other. So kinetic energy of translation of the upper half of the disk will be half into m by 2 into velocity of center of mass whole square, which is equal to omega r plus omega r 4 omega r by 3 pi. And kinetic energy of rotation will be equal to half I omega square. And I know that you can find the moment of inertia of this object about this point. How can I do that? Well, I know that the moment of inertia of this semicircle about this axis is mr square by 2. Therefore, ICOM should be equal to mr square by 2 minus क्यों आ रहा है? Because हम ICOM निकाल रहे हैं. The center of mass है इसका. और ये दूसरी axis. ICOM is equal to I about the other axis minus mr square. So this will be minus m into 4r by 3 pi whole square into dv square. Right? So when you add this up, you'll get the kinetic energy of the upper half, and the kinetic energy of the lower half will be easily obtained क्योंकि उसमें kinetic energy of rotation will remain the same. आया समझ में सबको? Misunderstood? बोलो भाई.
Yes, sir.
Yes. फाइनल आंसर निकालना है. अपर और लोअर में केवल एक ही फर्क रहेगा कि ये वाला साइन यहाँ पे माइनस हो जाएगा. So work energy theorem. ये वो समझ में आ गया काइनेमेटिक्स वाला पार्ट पिक्चर.
हाँ सर, काइनेमेटिक्स वाला पार्ट आ गया.
Rotational mechanics. So I'm going to introduce the theory to you by way of a question. And before I do that, please remember that the definition of work done was a very complicated object. If you remember, it was the line integral of a force, which is very different from normal integral. Torque की वजह से जो work done होगा, that will also be something very similar. But since we are not going to discuss two-dimensional objects here or three-dimensional objects, therefore work done. So this is the work done by force. Work done by torque will simply be equal to integral torque d theta, and this quantity is positive if torque and d theta have the same sense of rotation. I'm not going to use the word direction. I'm going to use same sense of rotation. That means that if both are clockwise, if both are anti-clockwise, then you get positive work done. You get the work done to be negative if torque and angular displacement have opposite sense of rotation. Please don't think of it in terms of dot products. If your hand is forced, नहीं भाई आपको torque is something I cap, something J cap, and theta is something I cap, something J cap, then you can work out the torque product, no problem. But I don't think that will ever happen. Okay? Now, I want to find out the work done by a torque. नहीं शाना वही मैं बोल रहा हूँ इसमें भी डॉट प्रोडक्ट हाँ
सर आप वो प्लस माइनस वाला पार्ट रिपीट करोगे क्या? सुनाई नहीं दे रहा।
मेरे को बताओ कि वर्क डन जो 10th में सीखा था याद है वर्क डन पॉजिटिव कब होता है और नेगेटिव कब होता है बताओ जो 10th में या 9th में जब भी वर्क एनर्जी पढ़ा था तो क्या सीखा
जब डिस्प्लेसमेंट और फोर्स एक ही डायरेक्शन में होता है तभी पॉजिटिव।
yes right so that was a very simplistic kind of a definition अगर वर्क और अगर फोर्स और डिस्प्लेसमेंट सेम डायरेक्शन में है तो वर्क डन पॉजिटिव होएगा और अगर फोर्स और डिस्प्लेसमेंट ऑपोजिट डायरेक्शन में है तो वर्क डन नेगेटिव right so what I'm doing is that I'm using that same simplistic explanation here also for work done by torque okay? So I'm saying that look if torque and angular displacement have the same direction the work done by the torque will be positive and if the direction of torque and angular displacement is opposite then the work done will be negative. Now I can talk about the direction of torque and angular displacement. You do know about the direction of torque and angular displacement. You'll have to use the right hand thumb rule and so on. But since we have been talking about two-dimensional or one-dimensional torques only, we have been talking about anti-clockwise and clockwise torque. So here also I will extend that. I will say that look, let's say that the torque is either anti-clockwise or clockwise now. Now let's decide whether the work done will be positive or not. Very easy to do. Work done will be positive if the torque and angular displacement are in the same direction. आया समझ में ना जो मैं बोलने की कोशिश कर रहा हूँ and अगर opposite sense of rotation हुआ तो opposite direction हो गया नेगेटिव हो जाएगा वो okay so this is what I want you to do I'm going to change the screen. So I'm going to introduce the theory in form of a question and I think इसके आगे मैं करा नहीं पाऊंगा next question. So we have a rod of length L, mass M. And the rod is suspended from this point. So this is the point of suspension. So the rod is released. Find the torque on the rod when it makes angle theta with horizontal. Therefore, find work done on the rod by gravity as a function of theta. नहीं शौनक यस नहीं शौनक तेरा देखना कोसाइन और उसमें गड़बड़ है ना मेरे ख्याल से क्या ना चाहिए साइन या कोसाइन नहीं नहीं कुछ गड़बड़ किया ना शायद नहीं शायद मैंने ही गड़बड़ किया so when this rod is at an angle of theta like so then torque on it will be mg L by 2 cosine theta right mg fixed point के about torque निकालना है
सर मैंने वर्टिकल से लिया था थीटा।
लिखा हुआ है बे ना तब भी तेरा आंसर सही है अगर तूने वर्टिकल से लिया तो आंसर सही वर्क डन is integral of torque d theta is equal to mg L by 2 cosine theta मेरा आंसर गलत है शौनक क्योंकि जब इंटीग्रेट करेंगे ना और इंटीग्रेशन में कोसाइन थीटा आता है तो थोड़ा केयरफुल रहना पड़ता है बिकॉज कोसाइन जीरो इज नॉट जीरो इट्स वन लेकिन अगर साइन आता है तो कोई प्रॉब्लम नहीं
सर ओरिजिन से एंगल लेंगे ना
इनसे एंगल लेंगे
मतलब जहाँ ओ से वो फिक्स है तो वो 90 प्लस थीटा नहीं होगा
if the rod is released find the torque on the rod when it makes an angle theta with the horizon rod ऐसे सस्पेंडेड है ये पॉइंट ऑफ सस्पेंशन है जब रॉड को रिलीज करेंगे तो क्या होएगा व्हाट इज rod will rotate because it is suspended therefore cannot translate agree to this आया समझ में परीक्षा में क्या बोल रहा हूँ
हाँ सर समझ गए
so this will come out to be mg L by 2 sin theta now where is L by 2 sin theta what is L by 2 sin theta what is L by 2 sin theta
जितना डिस्टेंस हो नीचे आए
क्या नीचे आया
सेंटर ऑफ मास
so L by 2 sin theta is the vertical distance traveled by the center of mass. This is the vertical distance traveled by the center of mass. So I'm going to change the slide and I'm going to come to the main point now. So the main point of the exercise is that look, just like forces can do work, in exactly the same way, torques can also do work. And in keeping with our understanding of the separation of the realms of translational motion and angular motion, we can still say that look, the work done by a force and the work done by a torque due to the same force are separate entities. Work done by work done by a force which is acting on a body, right? And it is responsible for translation of the body, may also be providing a torque, right? And in that case, that same force will also do work as a torque. What does this mean? If a force is being applied on a rigid body in such a way that